let's continue on talking about the transformations of trigonometric functions. So we've seen the base graph of y equals sine x and y equals cos x. And then you've also seen the transformations of A, which is our amplitude, and C, which is our sinusoidal axes. So we've seen those two transformations. We want to continue on. I'd like you to go to the Desmos calculator link here. You can also find it in your Google Classroom. And I'd like you to play around with when you have something in brackets. So for example, cos bracket x minus d, or sine bracket x minus d. What happens when we have that number in there, and how does it transform your function? So go there, take a look, and play with it, and then come back and we'll get started. Okay, so what you were examining in Desmos was the y equals sine x minus d function, and probably what you saw is that it moved it left or right. So we don't actually call it a horizontal translation anymore. We now call it a phase shift. So with sinusoidal functions, it's called a phase shift. And all it does is move your graph left or right. Now, just a quick reminder, when you take that value outside of your brackets, it does change signs. The reason for that is because you're actually setting that x minus d equal to 0, and you're solving for d. So if I want to solve, or sorry, you're solving for x. And so if I move d to the other side, I have to add d to both sides, and we get x equals d. So it will change signs as it comes out of your brackets, and that's your phase shift. Okay, so we're going to take a look. We're going to graph a whole bunch of functions, and I'm actually going to use my table of values now to help me. I feel like as we look at more and more transformations, it's important for us to know how to use the table of values in order to organize our transformations and get our points. So even though for these next few graphs, we're going to look at graphing, there's only one transformation, I'd still prefer for you to use a table of values. And this table of values, remember, is a y equals sine x. So that's the function that looks like this. Starts at 0, 0, goes up to 1, back to 0, down to -1, and then 0. Okay, so let's get started. So y equals sine x is the first graph. Oops. Pull that out. Okay, and let's create our table of values. So actually, I think I'll go below here. So y equals sine x is just here in purple. It's the function, the table of values that I just created. So it's this right up here. So if I go to graph this on my graph, I am going to start at 0, 0, and then at 90 degrees, I'm at 1, and then at 180 degrees, I'm back to 0, and then at 270, I'm at -1, and then at 360, back to 0. And so what we get, kind of extend it out here, is this purple graph. Of course, it continues on, so I'm going to put arrows at the end. All right, let's take a look at the next graph. So the next graph, let's pull out B here, is y equals sine 2x. So that 2 is in amplitude. So let me pick a different color here. So that's my amplitude. And it's going to change my table of values a little bit in that. Let me just set it up here. So I start with my base graph. So 0, 0, 90, 1, 180, 0, 270, -1, and 360, and 0. And that 2 in front is being multiplied to our whole function. So we're going to multiply all our y values by 2. So when I do that, I get 0 times 2, which is 0, 1 times 2, which is 2, 0 times 2, which is 0, -1 times 2, which is -2, and 0 times 2, which is 0. So this is going to have points at 0, 0, 90, and 2, 180 and 0, 270 and -2, and 360 and 0. Okay, so let's go to my graph then. And so y equals 2 sine x. And we're going to do this one in blue. So according to my table of values, it was still 0, 0. At 90, it was at 2. At 180, it was at 0. At 270, it was at -2. And then 360, it was at 0. So we can see how it is. It's kind of like vertically stretched it out, but it keeps the x-intercepts the same. All right. Now let's go for C. So C is going to give me, just extend my page down here. Let me change my view. Oops. View. All right, let me just scroll right down here so that we can see this nice and big. Okay, sine x plus 1. So this is my sinusoidal axis. And it's what is moving this up or down, right? This causes a vertical translation. In this case, it's up 1. So let's start. So I start with my base graph again, which is my sine graph. So 0, 0, 90 and 1, 180 and 0, 270 and -1, 360 and 0. And this plus 1 is added to the whole function. So I'm going to add it to my y values. 0 plus 1 is 1. 1 plus 1 is 2. 0 plus 1 is 1. -1 plus 1 is 0. And 0 plus 1 is 1. So these now become my new points. All right, so let's go ahead and plot those on our graph. There we go. And this one is going to be in red. And there we go. So I can see the whole page. All right. So at 0, it was at 1. And then at 90, it was at 2. And then at 180, it was at 1. And then at 720, it was at 0. And then, whoops, kind of made a mark there. At 720, it was at 0. And then at 360, it was back to 1. So if I connect these, I should have my sine graph that's been moved up 1. That's exactly what it is if you compare it to the purple. All right, last one. So let me grab D. And this is where we're going to put in our phase shift. Scroll down. All right, so let's do the phase shift. And let's do this in green, let's say. So this is called a phase shift. Really, it just stands for moving it left or right. And this is going to be 90 degrees to the right. Okay. 0, 0, 90, 1. 180, 0, 270, -1, and 360, and 0. Okay, now phase shift is moving this left or right. Notice that 90 degrees is being subtracted directly from the x. So we're going to go over here to our x values. and I'm going to add 90 degrees. Now, what should make sense is that X is in degrees and this is in degrees, so that's why it's going to affect the X value. I'm going to add 90, so I'm going to get 90, 180, 270, 360, and 450. So my new points will become 90 and 0, 180 and 1, 270 and 0, 360 and -1, and 450 and 0. Okay, and these will be the ones that we want to plot over here on our graph. Here we go. And that was in green. All right, so my first point then is at 90 and 0. And then it was at 180 and 1. And then 270 and 0. And 360 and -1. And then I go off my grid. So I'm actually going to fill in back here. So remember, this is all a pattern, right? So it starts middle up, middle down, middle up, middle down, middle up, and so on. So I can work backwards. So I have up, middle. So that means here at 0, I would be at -1. And now, whoops, I'm a little off on my drawing here. Now I can connect. So that looks like our sine graph, but instead of starting here at 0, 0, it just got moved 90 degrees to the right and started here instead. Okay. So let's try this, except with like a bigger function. So this is really why we use a table of values. So when we have something along these lines. So let's start. Let me do this in blue. So cosine, so 0, 90, 180, 270, 360, and starts high. So it starts at 1, 0, -1, 0, then 1. All right, now remember, when we are doing our table of values for our graph, we always want to go from left to right. And anything that we encounter, that's what we're going to go ahead and adjust our table of values for the following. So let's start. I have a -3. So the negative, of course, tells me there's a reflection in my x-axis. The 3 tells me that my amplitude is 3. What it means for my table of values, though, so let me just kind of move this table of values down, is that I want to multiply all my y values by -3. And when I do that, I get -3, 0, 3, 0, -3. And then as I come across, I hit this -60. So of course, when it comes out of the brackets, +60, it's going to get added to all my x values. So 0 becomes 60, 90 becomes 150, 180 becomes 240, 270 becomes 330, and then 360 becomes 420. And then lastly, we have this +2. So the +2 is being added to the whole function, which means I'm going to go back to my y values. And I want to add 2. So -3 plus 2 is going to give me -1. 0 plus 2 is 2. 3 plus 2 is 5. 0 plus 2 is 2. And -3 plus 2 is -1. And now that tells me that my points are going to be at 60, -1, 150, 2, 240, 5, 330, 2, and 420, -1. All right, so this is what we're actually going to want to throw on a graph. I'm not going to remember those, very well. So let me actually, I'm going to grab them all, and I'm going to copy them and bring them over here. Paste. There we go. Okay. I'm not sure where I should put them so they're out of the way, but I can still see them. So maybe actually what I might do is make them smaller. There I go. So that they're not so in my way. Okay. And I think I'll change my color. So let's go to red. All right. So 60 and -1 is here. And 150 and +2 is here. And 240 and 5 is here. 330 and 2 is here. And then 420 and -1 is here. So what I have then, so that's my lowest, that's my highest, it looks something like now I could actually continue on. I can see what's happening here. Like every 90 degrees, it's the pattern continues, right? So if I go 90 degrees from 420, which is just over 3 spots, 1, 2, 3, then I would have my next spot, which is here. And then 1, 2, 3, my next spot, which is up here. And then 1, 2, 3, my next spot, which is here. So I could continue on and draw more than one cycle just by continuing my pattern, right? So just by knowing and seeing the pattern, I can keep going with that. There we go. So I'd like you to practice some of this stuff. And of course, as always, if you have any questions or concerns, make sure you reach out to me.